Mr. Prashant Marathe is very busy and highly sought out trainer. So thank you so much, Mr. Marathe, for agreeing on our request to give a date today, and we warmly welcome you all. I see Mr. Anuruddha Puranik. He is a very excellent quality professional. He is with us. Madhav Borvankar is also with us. Okay, thank you for coming. And I am pleasantly surprised to see Kritika Ingorani. I think that L&D she seems to have taken very seriously. This is a very good thing to learn on very new area. What is FMEA? And from one of the best trainers, Mr. Prashant Marathe. So welcome to you and all of you, others all. My old colleague Samadhan has also come all the way from Gujarat. I will just introduce you very briefly to Pune Management Association, then my organization, that is Pune Divisional Productivity Council. My name is Pramod Wadikar. I work with PDPC. Pune Management Association is now 45 years old trust. Pune Divisional Productivity Council is 63-year-old trust. Okay, both. PMA was started by Dr. Kallani, Shantanu Kirloskar, Mr. Vasan Rao Vaidya of Swastik, and a banker, Mr. George. PMA focuses on wide range of services to improve standard of management practices. So it is a very broad and wide canvas. During Corona period itself, when activities had come to standstill, PMA has taken a very big leap initiative to have a webinar as a part of their objective. And I think I am happy that they have conducted so far more than 250 webinars on various topics. In last couple of years, I think PM has undergone a big structural change. And now they have what they call Center of Excellence. And there are 14 Center of Excellence. All 14 Center of Excellence are independent. And they are in the different area like entrepreneurship, mentoring. It's all gamut of management. All the people who are working here for the center are purely on voluntary basis, and they are all top class professionals. Okay, so PMA is very vibrant and very active through these centers. Okay. If you look at the PMA's website itself, I think in February itself they must have something like 9 or 10 programs. In March they have 7 programs. So this speaks of the vibrancy and activities of PMA. In addition to what you say webinars, there are many more other activities also for their objectives. Government of India declared every year 12th February to 18th February as National Productivity Week. Okay. So under that we had 2 programs, and now on 22nd February we have program on FMEA. Okay. PDPC is also a trust, and we help organization in providing solutions to their problems, particularly in the aspect of efficiency, utilization, capacity, productivity, manufacturing cost, and employee performance. Talking some of the areas. We are also into training. We have trained more than 35,000 employees of manufacturing organizations. We had also provided consultancy to maybe 450 plus manufacturing organizations of all sizes. Okay. We have also started consultancy in the field of staff studies, store, warehouse, logistics for 3 years back and got many assignments. We are also entering into Industry 2.0 IIoT solutions. So, and now we are focusing more on SMEs. Our recent effort has indicated that 30% of the SMEs have shown a lot of interest in us. So that's very encouraging for us. Mr. Marathe, I was privileged to know him for several years. and he has been helping PDPC in training and consultancy activities. I don't want to take much time. I have already taken 5 minutes. So I request my colleague Apurva to briefly introduce Mr. Marathi to all of you, those who are not knowing him, and then Mr. Marathi will take over. Thank you so much.
Good evening, everyone. It is my pleasure and honor to announce our today's speaker, Mr. Prashant Marathi. Prashant sir is a dynamic techno professional with experience of more than 30 years in automotive industry. His areas of expertise are quality systems, operations, business excellence, Lean Six Sigma, process and product development, and many more. Along with his BE degree in production from VGTI College, Mumbai, MBA from Indira Gandhi University, he is certified black belt in Lean Six Sigma. He is lead auditor for ISO and qualified external assessor for Tata Business Excellence Model. He is also certified in Z Master Trainer and Assessor under the Make in India initiative by our Government of India. He has also done training on advanced techniques in quality systems from Brico Engineering UK and Sinder Tech France. He has a proven track record of achieving high production targets by designing and implementing quality systems to increase operational efficiency. He has worked for 26 years in various industries like Mahindra Mahindra, Tata Group, Anand Group, Tyco Group, etc. At various levels, including plant head and general manager in these industries. Currently, he is a successful self employed consultant and trainer for quality and productivity improvement projects. He has helped and trained many organizations on lean management, Six Sigma, Quality Circle, TQM, TPM, Kaizen, QMS, and the list goes on. He is an expert in the latest standard and edition in quality, which is also our webinar topic, that is AIAG-VDA FMEA. So I please welcome our keynote speaker, Mr. Prashant Marathi. Thank you. Prashant sir.
Yeah.
Prashantji, before you start, just one announcement and one question for audience. Yeah, this is Pradeep Tupe, Vice President of Pune Management Association. First, start with the question. A couple of months back, when we started series for the production and manufacturing related subjects, we had sought your opinion. What is the preferred time? Whether it is 7:30 or 8 or something different. So just write in your chat box what is the preferred time. So that will help us, because last time the opinion was 8 o'clock would be better because you people are traveling and reach home at around 8. So just give your feedback. And secondly, today's topic, we are planning to have a full day or half day, you can say workshop. So those who are interested, please write that also in your chat box. Thank you.
Thank you.
Yeah. Shall I start?
Yes, sir.
Yes, sir.
Yeah. Okay, thank you. Thank you very much for my nice introduction and kind words. First of all, I am very much thankful to PDPC and PMA management for giving me this opportunity to come on this particular very well and renowned platform. I am thankful to Mr. Wadikar sir and Tupe sir for inviting me and inviting me to talk on this particular subject of AIAG-VDA FMEA. So I will straight away go to my PPT is visible to.
Yeah, it is okay.
And
yes,
I am audible too.
Visible.
I hope I am audible too.
Yes, sir.
Okay, thank you very much for confirmation. Yeah. So friends, good evening to everyone. On behalf of Apex Business Excellence, of which I am a founder, In association with PDPC and PMA, I welcome you all for this 1 hour webinar on AIAG-VDA FMEA. So FMEA is failure mode and effects analysis. Probably everybody is aware of this. So the agenda for my discussion will be, I have categorized this talk in 2 sections. First section will be introduction. So in that, I will cover quickly FMEA history, then introduction to FMEA, and DFMEA and PFMEA. So DFMEA means design FMEA, and PFMEA means process FMEA. And in section 2, I will be covering FMEA methodology, which will basically cover 7-step methodology of FMEA and key changes in new FMEA. I know that many of the participants may be interested in knowing what are the key changes in new FMEA, because recently, I will not say recently, in 2019, actually, this particular standard is revised. And there are a lot of changes in this new edition. So I will be talking about those changes and certainly the new format for FMEA. So friends, basically this is a very vast subject. FMEA is a very, very vast subject. And just to tell you that this DFMEA, if you want to sufficiently understand this particular concepts of this FMEA, at least 2 days for DFMEA and 2 days for PFMEA actually are required. So now it is a very daunting task for me to cover this particular subject in 1 hour. So friends, what I will do, I will not much talk about the theory part, because almost everybody, I hope that everybody is at least aware of this FMEA, because this is not a new technique, even though there are quite a few changes. This is a very, very old technique, but very, very useful. So I will concentrate on the practical aspects of this particular subject, and mainly the implementation part. So definitely I will be covering some of the case studies, some of the actual practical examples, then the logic, purpose, and the intent behind this particular thing, and so that it will be helpful for you in implementation of this particular technique in your organization. So starting with the history of FMEA, in 1949, so FMEA was first developed by US military specification, that MIL standard, it is commonly known, that MIL P1629. So this was developed in 1949. So more than 73 years have been passed. So you know that's how old this particular technique is, and that's why I've made a statement that most of you must be aware of this particular, at least what FMEA is. So, and you can see that there are a lot of standards which have origin in MIL standards, that's military standards. So this FMEA is also one of them. And afterwards, the real implementation or application of this particular FMEA technique was done in 1963 by US organization, that is NASA, National Aeronautics and Space Administration, basically for their Apollo project. So when they wanted to send a man to moon, so this was a very big project, and that time they actually, in fact, it is this need was realized when actually they were working on this particular project. So they were actually manufacturing so many prototypes. So in fact, why do we manufacture prototype? So to have less failures in the final product. But they observed that even prototype also having too much cost, because this satellite project or space shuttles, you know, this is a huge cost. And then they realize, why can't we prevent this even before the prototype manufacturing? And that's how actually this particular need actually they realized, and they successfully implemented this. And not only they reduce the cost, but they actually reduce the time that for the project time that they completed in well within the target. So afterwards, then the other industries and other sectors also realized the use, and then it was then used in aviation, aerospace, nuclear power, and all other sectors. In around 1965, in 1985, actually it entered into automotive industry. In fact, automotive industry started this in 1980. So that way it was a quite late entry in automotive industry. So in Germany, actually it was first developed in DIN standard. So there is a national standard, DIN standard. And this was actually developed by the association called as VDA. So VDA's long form is Verband der Automobile Industry. So that is the association in Germany for vehicle manufacturers and suppliers. It is just similar to our CM, like Society of Indian Manufacturers Association, or ACMA, that is Automotive Components Manufacturer Association in India. So it is a similar association which developed this particular standard. And then they started revising that particular standard periodically. So volume 4 was released. Then again they bifurcated that into DFMEA and PFMEA in 1990. And in 1993, in fact, the AIAG, another association which developed this particular reference manual, and the main players in that were basically Ford, Chrysler, and General Motors. Popularly, they are known as Big Three. If you know that around 1990s, actually, they were having almost 95% of all automotive vehicles market share worldwide. And then the association, that is Automotive Industry Action Group. So basically, there are two standards worldwide. One was from VDA and one was from AIAG. So basically, VDA was basically the European standard, and AIAG was American standard. So practically, we cannot say that this was one common standard worldwide, because the supplier to European OEMs, they were asking their suppliers to meet the standards of VDA's requirements, and for the suppliers who were supplying to American OEMs, they were insisting upon the AIAG standard. And due to globalization, so the suppliers are now common to European and American OEMs, and then they realize that we have to commonize these particular two standards. And these two streams were actually, they were having their own revisions, like this AIAG and VDA, second edition, third edition, fourth edition. So in 2008, actually the AIAG has fourth edition. But in 2019, actually both these agencies came together and they released their joint standard on FMEA. So now it was easy for the suppliers to meet the requirements of both the customers. And that's how actually they released this particular standard in 2019. That is called as first edition. So many people are actually asking this particular question, why this is not the fifth edition? Because the earlier edition was the fourth edition, but that was for AIAG. But jointly they have released this particular standard for the first time. So that's why this is the first edition in 2019. And we will just have a quick, I will say the basic points of FMEA. So the failure modes and effect analysis, that is FMEA, is a team-oriented exercise. It is a systematic exercise, and this is a qualitative tool and analytical tool to evaluate the potential technical risk of failure. So basically, it addresses the potential technical risk. So it is different from the actual failures. So it is basically thinking that what could go wrong. So that will lead to your potential technical risk. So it may be related to product or related to process. Related to product, you will get DFMEA, and related to process, it will give you PFMEA. So basically, it is somewhat similar to, I will say, the Mungeri Lal Ke Haseen Sapne, which is quite famous serial some years back. So it is something thinking in future, ki what could go wrong. But the difference is, it is not only the Mungeri Lal, but it has to be done by the team. It is not the one-man show. It is to be done by the team. That is the requirement. And definitely, the team will identify the failures, and again, it has to be a systematic way. It is not like that just sitting in a meeting and just discussing what could go wrong, or ये मेरा particular product है. Maybe let us say there is a steering unit in the vehicle. तो मेरा steering unit किस तरीके से fail हो सकता है. So let us discuss कि उसके failures क्या है. Not like that. So there is a systematic way of identifying these failures. Why it should be a systematic? So we should not miss out any failure, and so that we can prevent that failure, that particular potential failure which is right now, so which should not rather convert into the actual failure. And one more thing, it is a qualitative tool. It is not a quantitative tool. So there may be some subjectivity, there may be some slight variance, but because of various guidelines and directions, so this particular variation they have minimized. But we have to understand that it is a qualitative tool, so it is not like 2 + 2 = 4. So after identifying this particular potential risk or potential failures, then we have to analyze what is the cause for that particular failure and what is the effect or what are the effects of that particular failure, so that we can understand so what is the severity of that particular failure, and we can prioritize that. So that is also one of the things. And there is a very strong linkage between IATF 169 standard and FMEA. So I will not discuss in detail, because many of this automotive customer who are there from the automotive industry, they know that. So this is a standard requirement, and you can find this FMEA at various places, at various clauses. Okay, so you can see that various places this particular FMEA is mentioned. So even for internal auditor competency, they have mentioned that the auditor shall means mandatory requirement in IATF terminology. So they should know or understand this particular PFMEA in detail, and even any changes, external changes in this particular standard, like this ISO or IATF. So they must be aware of those particular standards in their organization. Okay, so this is the linkage between this particular IATF and FMEA. But the word of caution. So this basically, even though I have mentioned this particular linkage and standard requirements, but this is just a compliance requirement. Okay, so FMEA, if you do for just compliance, so you will not get the desired effect and desired results. So we have to have an approach of improvement. Okay, so if it is just a compliance for the compliance purpose, if just for maybe if you are thinking that you should not get any NCR or non-conformity in the external audit, or it may be the PPAP requirement, which is the mandatory requirement of the automotive OEMs, that the supplier should complete PPAP and complete those 18 documents. So out of that 18 documents, so the FMEA is one of the requirement to just comply that particular requirement, because without that you cannot send a single component to the OEM. So if you do it for compliance, then definitely that cannot guarantee real benefits. So that many times it is actually many people say that even we do FMEA, still there are a lot of failures in actual production and supplies, because we are not doing it for improvement. And when we do it for improvement, I'm sure those particular failures, if not eliminated in totality, but definitely the number of failures will reduce. Okay. Just in the last week, I was discussing with Wadikar sir. So I am doing the projects in various industries. One of the project, actually, we are doing it in Parle Group. For the Parle biscuits, actually, they are doing this FMEA as well as SPC. So for controlling the biscuit weight and the biscuit height. In fact, that is not actually mandatory or any compliance requirement for that particular food industry. Even though they are doing it for the improvement purpose. And maybe that is the reason why these brands are there maybe more than 50, 60 years, in spite of their lot of competition with the foreign brands. So basically, we have to work for the improvement and not for the compliance. So, and one more thing, this particular technique, even though this was actually this particular FMEA more common in automotive industry, its application is actually practically not limited to this particular or not limited to any industry as such. It can be applied in food industry. It can be applied even in educational institutes. It can be applied in non-manufacturing environment like service industries. Because whenever we say failures, so failures can happen at everywhere. It can happen in manufacturing as well as non-manufacturing industry. Only in manufacturing industry, we can call it as defect, and in non-manufacturing or service industry, we call it as error or mistake. So it can be applied to any industry, any application, any product, any service. So there is a very close relation between FMEA and cost of quality. So the cost of quality basically has 4 components: prevention cost, appraisal cost, internal failure cost, and external failure. So I will not go in the details of this particular aspect. Again, this is a separate topic as such for 1 day or 2 days. So basically, our FMEA is whatever cost we are having that for FMEA, maybe the time of those particular FMEA team members, or maybe certain preventive measures we have to take. Very small investment may be required, but with that we can definitely reduce the other 3 types of cost. That is appraisal cost. Appraisal cost means basically the inspection and testing cost. Internal failure cost and external failure cost is basically whatever failure happens in the organization. So maybe your rejection, rework, scrap. So that is basically internal failure. And external failure means the failure actually happens after your product goes out of your factory, or you actually give service to your clients. So at that time also you may have customer complaints, maybe rejection, maybe warranty failures. So a small, I will say, the investment in this prevention cost, so we can have substantial reduction in the cost in other areas, and so that we can reduce the total cost of quality. And a good FMEA definitely reduces this cost of quality. So here I have purposely written a good FMEA, because as such, the only FMEA will not reduce the cost of quality, because if it is for compliance, again I am repeating, but if it is really for the improvement purpose, then and then only it will reduce the cost of quality. So now I will quickly touch upon the key changes in FMEA, and it will be later on discussed in detail in the subsequent slides. So the basic change in this particular standard, on the left hand side, you can see this particular blue color standard. This is the AIAG 4th edition standard. So that was in blue color. And this on the right hand side, so that is a VDA standard for FMEA, that is in red color. And at the center, you can see that this particular, the new edition. So you can see that half portion is blue. This is the top cover of this particular standard. So half portion is blue, representing AIAG, and half portion is basically red, that is representing VDA. And at the bottom, you can see this is written as a first edition 2019. The second change, and I will say this is a very big change, I will say. So they have introduced a 7-step approach. And what are those 7-step approach? These are the 7-step approach. So definitely in subsequent slides, we'll be discussing more on this particular 7 steps. So why actually they have introduced this particular 7-step? To make it more and more systematic. So to have basically anything should not be missed, and the quality of that particular FMEA should be good. So basically for making it more systematic, in one of the earlier slides, we have seen that it should be a systematic. So they have introduced this 7-step process. So if you know this particular older standard, so that is the 4th edition standards. So there was the first column as process step and function. So in this process step, so in the new standard, they have actually bifurcated into 3 steps or 3 columns. So that is process item, process step, and process work element. And the other half portion, that is function, that is also actually they have bifurcated into 3 columns. That is function of process item, function of process step, and function of process work element. Okay, so that means earlier standard, in earlier format, there was only 1 column. So now for that particular column, there are 6 columns. So somebody may argue that now it is this is a tedious or the work is more in this particular new standard. But let me assure you, because of this, it is so much simplified. It is so easy to do FMEA. Definitely, if you know this basic or the intent of that particular thing. So just to have a glimpse of this particular old standard and new standard, I will just show you. So this is basically the old standard. And in today's talk, certainly I will be discussing about mainly about process FMEA, but that is applied to design FMEA. So this first column, that process step function, is now converted into the 6 columns. Like in structure analysis, you can see that. So there are these 3 columns, and in function analysis, there's another 3 columns. So these 6 columns are there. So we'll quickly discuss that also. So other changes are, they have changed the sequence of failure mode, effects, and causes. So now the sequence is failure effect is first, then the failure mode, and then the failure cause. This is quite logical. If any failure mode is there, friends, any failure, so which will happen through certain mode, and for that particular failure mode, it will have certain effect, right? So that is the failure effect. Basically to the customer. Customer may be your internal customer or external customer. So failure mode will result into failure effect, and to occur the failure mode to occur, to happen, there are some causes which are responsible for that failure mode. So causes will result into failure mode, and failure mode will result into effect. That is the sequence they have now changed in this particular new standard. And that is quite logical. And there are quite small changes, like they have clarified the special product characteristics. Earlier it was classification. And the one more biggest change, that earlier that RPN, risk priority number, now they have changed it to the action priority. That I will discuss in detail. And in risk analysis, all the 3 tables, that is severity, occurrence, and detection. So all these tables are redefined. Oh, so this basically the severity, occurrence, and detection, basically S, O, and D. So for the severity, there are ranking from 1 to 10, as well as for occurrence and detection. And the ranking that 1 to 10 is same in the new standard also. But the criteria of that particular this particular SOD, those were totally changed. These particular tables are totally, I will say, revamped. And earlier, what we used to do for RPN, So we used to do S into multiplication of all these ranking, right? So SOD is basically RPM number. So now that is totally removed from the standard and it is replaced by action priority. Again, as I mentioned you, this is a qualitative tool. So RPM number, actually it was giving some quantity. So multiplication of this SOD, so ranging from 1 to 1000. So now this particular action priority is either only H, that is high priority, M is medium priority, or L is low priority. So they have converted this from quantitative to qualitative parameters. And that's why there was unnecessary too much discussion on this, what is threshold limit for this RPN and what should be the ideal value of RPN. Now everything is they have removed. And the separate AP table is introduced. So similarly for recommended action, they have bifurcated it into preventive action and detection action. And the status column is also included. So now let us discuss with the case study. Let us say there is a, suppose, let us say there is an electrical motor manufacturer. Okay. So electrical motor manufacturer, electrical motor of a window glass this is a power window in a vehicle door, and for that basically the window lifter mechanism is there, and then that window lifter electrical motor is there, basically which is used for movement of the glass either upward or downward. This is a power window. So basically there is a OEM. Then for OEM, this door manufacturer is let us say tier 1 supplier. Maybe for that window lifter mechanism is supplied to tier 1, that is tier 2. And maybe the electrical motor is tier 3 supplier. So now if we want to implement this particular FMEA for this electrical motor manufacturer, then we'll see how to do that particular FMEA for this electrical motor manufacturer. Along with that, I will also explain some of the other examples. But if the electrical motor manufacturer is there, so basically this is our focus element, that is electrical motor, and this higher assembly is basically the window lifter, and the lower assembly maybe there can be sub assemblies, components in that electrical motor. So that is on the right hand side. So for doing the DFMEA, so this is basically the structure, and for doing process FMEA, we will see what is the process for manufacturing the electrical motor and what are the steps. The steps will be the focus element, and we'll see the higher level and lower level of that particular process step. So basically, we'll, as I mentioned, we'll discussing about the process FMEA for this particular electrical motor manufacturing, and we'll go with the 7 steps. The first step is planning and preparation. So in this planning and preparation, first step is basically to describe the boundary. Basically, what is to be included and what is to be excluded in the FMEA. And the one more important thing we have to remember in process FMEA, that you have to cover all the processes which are happening in your organization. Don't worry about whatever coming from the supplier. So that should be addressed into the supplier FMEA. But whatever is happening right from the receiving inspection or receiving of the material till the dispatch of that particular component, because failure can happen at any place, isn't it? In receiving also there can be failure. Maybe that particular defective part or the lot having defective parts may be actually accepted or maybe made okay, and it will give a failure in subsequent steps like in production, or maybe at the last dispatch stage, maybe there is a activity of maybe that loading of that particular final packet into the truck. Maybe that time, maybe suppose if it is to be, just for an example, it is to be, say, it is to be loaded as upside in a particular direction. But if it is not in that way, maybe on the side face it is loaded, or it is upside down. So it can damage your product inside, and maybe at the customer end you will face this failure, even the manufacturing process is correct. So all the processes. And this another thing, you can cover all these in one FMEA, or maybe there can be separate FMEAs or combination of FMEAs. Maybe receiving FMEA is different, if dispatch FMEA is different, but all these other operations you can combine in one FMEA. But the important thing is it has to be addressed in FMEA. So in the first step, so you can see that this is a header, and this header is now very much simplified in the new standard. The only change they have made it is basically they have added basically this confidential level. As you know that there is very confidential aspects in FMEA. In fact, it is a very good knowledge base, and many areas or many things are basically very confidential and very critical for that organization, and they don't want to disclose that particular thing. And whenever it is basically patented product or patented process, or maybe there is a heavy competition in the market, so definitely the supplier or the organization doesn't want to basically get it leaked outside their organization. So to solve this particular problem, they have mentioned this particular field so that you can mention that either business use means anybody can use that particular standard, this FMEA standard, or the proprietary. Maybe this will not be given outside, but whenever customer can come, they can view that particular FMEA. And the third is confidential. So confidential means even the customer comes to your place, so you basically you have right not to show them. But definitely in the 7th step, last step is documentation. But even though you are not submitting the entire FMEA, but documentation, that is a summary of that particular thing, you have to submit it. And it is not only that you have to write here confidential, but it has to be backed up by any agreement, NDA agreement, or any minutes of meeting. And this particular header you can change as per your requirement. In step 2, basically this is structure analysis. Basically process flow diagram is the input for this particular step. And you know that there are a lot of process steps. For example, for this is a process flow diagram. For now, the electrical motor, and there is the operation 10, 20, 30, 40. Okay, so like that you have to see what is the basically structure of my FMEA. And then this is basically my electrical motor. So this is electrical motor assembly line, and it has got various steps like operation 10, 20. So center column, that is a focus column, that is basically process step. And the higher level is basically the electrical motor assembly line. Or in other words, I can say that if I complete all the operation from operation 10 to the last operation, so that is actually part of which bigger process? That is basically the electrical motor assembly line. And on the right hand side, on the lower lower level, basically these are the 4 elements. What are the 4 elements? Man, machine, material, and environment. Okay. So basically these are the elements which are required for each step. For example, for operation 20. So now the man is required. So you can write the terminology of your organization, maybe operator, associate. The which machine is required, maybe the greasing device is required. Which material here, actually indirect material is mentioned. So that is the grease. What is the, if any environment requirement is there, condition is there. So you can, for each step you have to bifurcate it into 4M. And the next step is basically, so basically this 4M, they have mentioned that man, machine, material, and the last one is actually the milieu. So milieu, this is a German word, the meaning is environment. But you can add the method and measurement also, just like the cause and effect diagram or Ishikawa diagram, we use 6M. Or even in that, in addition to the 6M, you can add fixtures, toolings, etc. as per your organizational process behavior. So basically, this is the Ishikawa approach we are utilizing. So the basic difference is in when we are using Ishikawa after the failure, right? After failure, we are actually preparing this cause and effect diagram. But in FMEA, we are doing this Ishikawa diagram before failure. So before failure, we are getting cause and effect diagram. That's the beauty of this particular standard. And why to wait for that failure to occur? If really you want to take action, it can be done before also. No? So that's the beauty of this particular standard, and it So this new standard basically actually help us to bifurcate all these causes in these different categories, and at the end we will directly get the causes classified under man, machine, material, and maybe 4M or 6M. In the function analysis, basically, whatever we have mentioned in the structure, so what are the functions of those particular elements that you have to write? That is nothing but the requirements or characteristic. It may be a product characteristic like dimension, geometry, etc. It may be a process characteristic like speed, feed, current, temperature, etc. Because to control the process, to have the right characteristic, so basically you want, if you want, let us say, the hardness, the proper hardness of your final product. Let us say hardness is a characteristic. So for getting that required hardness, you may be required to a specific temperature in a particular range of the oven, or the time or the speed of the conveyor. That is basically, those are basically process characteristics. So in combination of this characteristic, you have to basically control the process, and not only product and process characteristics. There are other requirements like legal and regulatory requirements. There, and these can be local, central, or even overseas requirements. Then industry norms and standards, then internal requirements like cycle time and production cost. In fact, this is also the function of that particular process step. Okay, now we have to analyze this particular process in step, operation 10, operation 20. So not only I require this particular hardness or the specification in required value, but it has to be completed in the specified cycle time or production cost. That means FMEA is not only addressing quality, it is addressing your productivity as well. So because that is also failure, if that operation has to perform in, let us say, 6 seconds, and if it is taking 8 seconds, even though I am getting the required characteristic, required hardness, but if the cycle time is more, that is the failure. Okay, so that can be also addressed in this particular function analysis. So that is what is actually written in function analysis. So maybe then you can write the whatever we have done in structure analysis, man, machine, material wise. So you can write the function also, the man. So now for each function there can be 1 or 2 or more than 2 functions. Similarly for machine, so there can be different functions. So it has to be mentioned the 4M wise. So this particular flow, they have taken from the structure analysis to function analysis, like function of the process item, maybe internal function, external function, or user function, or it may be for the process step or the function of the process work element. Okay, so basically after this function, then we move to failure analysis. What is the failure? So whatever actually, if the function, if that particular process step is not performing its function, or opposite of the function or negative of the function is a failure. Okay, and that is, these are the 3 columns as we have discussed: the failure mode, effect, and causes. Right. So so there are basically, it is not only the negative of failure or negative of function is the failure mode. So basically the failure mode has different categories like loss of function, that operation not perform at all. The partial function, that is incomplete operation, or degradation of function with degradation, degraded performance, or intermittent function, operation not consistent, or unintended function. I will give you example of this one. Let us say this is basically whatever case study we are discussing. This is, let us say, this is your window, and this window glass is there, and this electrical motor actually is used for lowering or moving that particular glass upward. So what is the loss of function over here? So even I press the button, the glass is neither moving upward nor moving downward. So that is total loss of function. What is partial function? That is incomplete operation. Means if I press the up button, so this particular glass is only going up to this level, it is not completely closing. So that is incomplete operation. What is degradation of function? So that means glass is moving completely, but it is very fast or it is very slow. So that is degraded function. Intermittent function. means operation not consistent, means it is not smooth. तो मे बी थोड़ा झटके देके जैसा वो अप एंड डाउन हो रहा है ग्लास का, दैट इज इंटरमिटेंट फंक्शन. अनइंटेंडेड फंक्शन मींस मैं लेफ्ट विंडो का ग्लास का बटन दबा रहा हूँ, राइट विंडो अप एंड डाउन हो रही, और मे बी let us say whenever it is not required, even if I am not pressing the button, it is moving upward and downward. Okay, so it is unintended. I don't want. So maybe suppose it is the vehicle is going through the pothole, and because of that impact, that suddenly that glass is moving upward or downward, and maybe that time that child can be maybe leaning out of the window, and maybe his or her fingers or even the neck can be trapped into that. So that is basically the unintended. So not having unintended function is also a function. Okay. Another example could be I will say airbag. So even though there is no accident is not there, that particular airbag is opening up. So that is a wrong operation. And there are various failure causes related to man, machine, material, and environment. I will not go in detail. So what could go wrong with the man? What could go wrong with the machine, material, and environment? That could be written in that causes. So quickly, I will show you the completed format of this particular structure analysis, function analysis, and failure analysis in the new format. So basically, if you can see, so the step 1 is just a header, but if you can see, there is a structure analysis. So this is the electrical motor assembly line, and for that, this is actually the focus element, basically process step, operation 10, 20. So now let us take operation 30. So for operation 30, man is required, press machine is required, and this is the flow now. Whatever is mentioned over here, so it will now be written in function analysis. So this third column is more important because this is the categorization of the all the causes. So due to paucity of time, I will discuss only the third column. So whatever is written man, machine, uska function kya hai? That will be actually in the third column of function analysis. And whatever function is mentioned in this function analysis. So for example, let us say this operation 30, that operator takes the sintered product and ensure that it touches the upper stop. What could be the failure of this particular man? The operator does not push that particular bearing up to upper stop, or it may be in some cases there are stoppers or locators. So whatever is opposite to this, but not only opposite. In the earlier slide, I have shown the different categories. So you have to list down all these particular failure causes. What could go wrong? So this particular column, we are directly getting this particular column. This is nothing but basically my cause and effect diagram. So friends, basically, if I say, so to summarize this particular 3 steps, so whatever is in structure analysis, basically I am writing 4M or 6M. So what are the elements in that particular structure? Okay, let us take 4M. Then what is the function of each element? Okay, let us say man. So it will have maybe 4 functions. So this is just an example I am writing. Okay, so similarly for each one there will be different function. And then what is the failure analysis? For each function, there can be different failure modes, right? So these can be different failure modes. And then for each failure mode, there can be different failure causes. So you can see this tree, so which is actually getting, so for this one, so you can see that, so how big will be FMEA? So FMEA normally runs into high number of, so this is basically the flow. If you understand this particular flow, so it will be very easy for you to understand this new FMEA. Obvious. So after identifying that particular causes, now I have to identify what is actually the risk analysis. So if, and then there can be a prevention control or detection control. Suppose this is the process failure, this can happen at this particular stage. So whatever is there on left hand side, that is the prevention, and on the right hand side, that is the detection. If I detect that particular, if I prevent that particular, let us say error or failure in the process B, that is basically a prevention failure. But immediately after that process B, if I am detecting it, so it is a detection, or in the next or subsequent process, station number n+1, that is also n detection. So I have to identify what is my prevention and detection control at present. Then I have to rate it according to severity, occurrence, and rating. And now, as I mentioned, I don't have to calculate RPN number. I have to just arrive at AP. So AP is basically just three option: high, medium, or low. So high priority, if it is, so there is a table. So you have to just select that particular rating from that particular table. Due to paucity of time, I cannot go into details of that. But I'm just mentioning, after looking at that particular table, you can either have H, M, or L. So H means high priority. That means action must be taken. It is a like a shall requirement in IITF or mandatory requirement. Should means it is a recommendation. It is and low priority means basically you can take or you cannot, but it is not necessary to have because take action because it has the low priority. Okay, so the M means it may be depending on your customer or maybe your top management or organization. So maybe they can have a mandate. Even for M also you have action. So action priority, basically it was created to give more emphasis on severity first, then occurrence, and then detection. Okay. So basically the RPN was giving equal weightage to severity, occurrence, and detection, because RPN was just multiplication of this. Just for an example, just to show this particular difference. Suppose my severity is suppose 9, then occurrence is 5, and let us say detection is 2. So RPN number will be maybe multiplication of this may be 90, and even if suppose my this order is reverse, like my severity is 2, my occurrence is 5, and detection is 9, the same figures got only on the reverse order. So now my severity is now from 9 to 2. So now it will be 9. So still my RPN is same. But if you look at the AP table, so this will show high priority, that is H, and this will show you L. And this is quite logical. So this severity is high. That means it may lead to an accident or regulatory non-compliance. So definitely it is a high priority. But since severity is 2 over here, so that is not so much, practically it is not critical. But RPN was showing same. But now it is very clear that, so this is high priority, but this is low priority. Okay, so we can see that, so just let me know how much time is there for me to go ahead so that I can.
The time is up.
Guys, take action on that particular aspect, okay, according to that priority. And then I have to just, in optimization step, what I have to write, what is the action? Again, here I have to write it, detection action separately and prevention action separately. And who is responsible, who is and the target date for completion, and all those things will come in the optimization step. So basically, it is the action or actions which are required to reduce the risk that will come in optimization. Then assignment of responsibility and target date, and that if it is implemented, then maybe the reference of documentation for completion. And after completion of that particular action, again we have to check the effectiveness. Okay, so and not only the effectiveness, that in the new particular change, that there can be new failure modes as well. So that's why we have to again reassess our FMEA and reassess the risk, and it should get lowered. So that is basically this optimization step. And the last step, so that's basically re-evaluation of SOD and AP after completion of all action. And this is nothing but a continuous improvement. And the last step is basically the result documentation. So whatever we have done, so that we have to write, just like at the end of the project report, we write summary, then some details, then maybe some results, conclusion. So whenever you say my FMEA is confidential, at least you give this particular summary, because customer is more interested. So what is basically the output of your or result of your FMEA? What is basically the priority, action priority, which action you are you are deciding to take on top priority? Then what is the conclusion? That is most important. At least you have to submit this particular report to your customer. And friends, to just have a glimpse of that particular total FMEA, I will just show you this particular now completely filled up. So up to this failure analysis, failure causes was the last column we discussed. So now the step 5, as I mentioned, so basically the step 5 is nothing but what are your current controls. Okay, and in optimization, basically, okay, in risk analysis step 5, it is not only the current control, but the rating of SOD and the AP rating. So you can see this either M, H or L in this particular column. And in the optimization step, so it is just deciding what is your preventive action and what is your detection action, whatever we have discussed. Now, for example, here in this machine, this particular failure cause was machine stops before reaching the final position. So operator का हमने cause क्या देखा था? He is not touching that particular component to the upper stop. But if the machine is not reaching to the final position, maybe because of machine problem, it is not operator's fault. So this cause, maybe I have certain controls, I will not discuss, but let us say they have now decided, since it is now the priority is M, so now they have decided to have this particular prevention action, select the press with position control sensor. So that sensor will sense whether that component is basic or that particular force is completely applied to that particular component. So this is, earlier there was only one column, recommended action, but because of these 2 columns, now it is very much clear which is prevention action and which is detection action. Maybe this will help me if it is a critical step. Maybe I will tell supplier that detection action is not sufficient for this particular step. You have to take prevention action. Or maybe there is a lot of failure, or there is a previous history. So I can tell him that in this particular column and for this particular step, you have to write. And if it is coming M or H, you have to write this prevention action. And other column like responsibility, targeted action, and then reassessment of that SOD and AP. So this completes our, now earlier M was there, and now after taking that particular action, this action priority is reduced from M to L. So that is the effective improvement. And to summarize, maybe the I'm coming to the end of this particular talk. So if I will say the recap of all these 7 steps, so definitely it is very logical. So for any process, like in PDCA, the first is plan. This is the planning and preparation phase. And I have shown this particular flow, that structure analysis means which are the elements in that particular FMEA structure, man, machine, material, क्या लगने वाला है. Then the function of each one. So that is basically the function analysis, मतलब structure to function and function to failure. So these 3 steps are very logical. And then after finding this particular risk, then we have to just analyze the risk by rating of SOD and AP. And after getting that priority, I have to just optimize it with some actions. So basically this is action and action plan. And then last one is the documentation. This is very logical. So even though that steps are mentioned in the format, these steps are very, very logical, and it is very now systematic and useful in this particular new particular standard. And as I mentioned, this can be applied to any product, any process. I'm sorry that I might not have covered all the things. I will skip this particular benefit. Everything is understood. by all.